Hey everyone, this is Miss Moriarty and I'm here to discuss with us topic 6.11, which is all about using hydrogen fuel cells. So looking at hydrogen fuel cells, this is an example of a renewable energy source. And here we're specifically using hydrogen as our alternative fuel source to fossil fuels. How hydrogen fuel cells typically work. Using hydrogen gas as well as oxygen gas would be our two inputs that we would use to generate electricity, while H2O would actually be the byproduct of this process. Looking towards the left, right in the figure 39.11 here, we can see that hydrogen gas enters the fuel cell, right? That's at spot number 1 that we see here. Here is where that hydrogen gas is then actually going to be split into its protons as well as its electrons. And then what's going to wind up happening is an electrolyte membrane is then going to be in between. However, this membrane does not allow electrons to pass through. It does, however, let the protons to pass through. So because of this, the electrons must take an alternate route, and in doing so, this can actually generate an electrical current. It is then our oxygen molecules, right, our other input, that's going to enter the fuel source on the opposite side of our membrane here. Those oxygen atoms are then going to combine with the protons from our hydrogen that passed through our electrolyte membrane to produce H2O, or water. Now, the most common application of hydrogen fuel cells would be using this to replace gasoline or crude oil that we tend to use to power our vehicles. Now, there is, however, a key issue with hydrogen fuel cells, right? We know it's a renewable resource, it doesn't produce any greenhouse gases, but the problem is making sure that we can isolate hydrogen gas, since it does not naturally occur on Earth in that way, and so we need to isolate it first. Now, what can we isolate it from? Typically, we can actually take water molecules, right, H2O, or even methane, CH4. We can do that through two different types of processes, one known as steam reforming, while the other is known as electrolysis. In steam reforming, we can take methane or CH4, we can burn the natural gas and use that to create steam to separate the hydrogen gas from the methane. But an issue in harnessing hydrogen gas this way is that it could produce CO2 and obviously requires a non-renewable fossil fuel in order to do this. The alternative to this would be using what's known as electrolysis. So here we can use an electrical current that could be applied to water as our source, breaking the O2 and then H2. Good thing with this is it's not going to produce any CO2 emissions. However, it is going to require an electricity source. And so the key challenge to hydrogen fuel cells is that it can be quite expensive in order to actually harness the fuel itself. So then that brings me to some of their advantages and some of their disadvantages. So hydrogen gas can be stored in pressurized tanks. It can be stored as a liquid or a gas, so it can be easily transported to different types of areas. We can use it as a replacement for gasoline in our vehicles for transportation. We can actually use the hydrogen gas that's isolated to create ammonia for synthetic fertilizers. Oftentimes in the chemical industry, hydrogen gas is used in a lot of manufacturing products, so we can use that harnessed hydrogen gas for that purpose as well. And we know that using our hydrogen fuel cells does not produce any greenhouse gases, does not produce any nitrogen oxides, particulate matter, ones in which would be emitted if we were to burn fossil fuels. Now, some of the disadvantages, however, we know now that a key challenge to hydrogen fuel cells is harnessing the hydrogen gas itself. If we happen to use methane to do this, this can release CO2. We would probably, if we were to go and now use widespread hydrogen fuel cells, we would probably have to do an overhaul of our infrastructure for a lot of cities and towns. That can be very costly and take a lot of time. The hydrogen fuel that can also be stored in a gas form in vehicles would also require much larger tanks than the current ones that they have. So we would have to see a lot of changes to take place in order to begin to see more implementation of hydrogen fuel cells. But that doesn't mean that, obviously, that's kind of where we are going in the future. Now, if you pause the video and in your notes somewhere, answer the practice FRQ question for 6.11. All right, at this point, you should have paused and answered the question, so let's take a look at the answer. So describe how a hydrogen fuel cell would power a vehicle. So we know hydrogen fuel cells are going to use our two inputs, such as hydrogen gas and oxygen gas, to produce things like water, heat, and electricity. The hydrogen gas will be oxidized right at the anode, meaning it's going to be split. Remember, our electrons cannot go through that electrolyte membrane. They must find an alternate route and head towards the cathode, which is then where it creates an electrical current. And we see the oxygen input reacting with the hydrogen that gets split to wind up making our water. All in all, this then converts the potential energy into eventually electrical energy for transport for the vehicle. All right, everyone, that is it for our video. If you have any questions, please leave that at the end.